We have been talking about producer surplus and consumer surplus and the equilibrium point. So let's do another example and we'll put everything together. Okay, this problem says, given X number of items, the demand function d of X equals 3,200 over the square root of X. And the supply function S of X equals 2 times the square root of X. Part A says determine the equilibrium quantity and the equilibrium price. And then I'm going to cross this off because this is actually question B. Okay, the equilibrium point. I'm going to set the demand function equal to the supply function. Now, initially, this does look a little scary. What we want to do is clear out that fraction in the denominator. And actually, if we multiply the left side by square root of X, that means we also have to multiply the right side by square root of X. These will divide out. On the left-hand side, I have 3,200. And then on the right side, when I multiply square root of X times square root of X, I get 2X. So X equals 1,600. This is going to be the quantity. The question says to find the quantity and the price. To find the price, all I have to do is plug this 1,600 into either function. So d of 1,600 equals 3,200 all over square root of 1,600. So this is 3,200 divided by 40. This will equal 80. All right, the X is quantity and the output is the price. All right, so the equilibrium point is 1,600, 80. This is the quantity and this is the price. All right, the next problem says to determine the consumer surplus. The consumer surplus is going to be the antiderivative from 0 to the equilibrium quantity of 1,600. Then I want to find the antiderivative of the demand function. The demand function is 3,200 all over the square root of X. Now, I'm going to rewrite this so it'll be much easier to find the antiderivative. The square root of X is X to the 1/2, but this was in the denominator, so that's going to be a negative 1/2. Then we subtract Q times P. All right, so let's find the antiderivative of 3,200x to the negative 1/2. This is going to be x to the positive 1/2, and then I need to account for the 1/2 being brought out here, so that's going to be 2, and the 3,200 was already there. I'm going to evaluate this from 0 to 1,600 minus 1,600 times 80. This top equation is the formula for consumer surplus. So that's all I'm doing. I'm just following that formula. Now I want to evaluate this integral from 1,600 to 0. So first I'm going to do 2 times 3,200. So that's 6,400 times 1,600 to the 1/2 and minus 6,400 times 0 to the 1/2. And then this will be minus 128,000. All right, this term there, that's 0. Then when I do 6,400 times the square root of 1,600, so 6,400, then the square root of 1,600 is 40. So 6,400 times 40 is going to be 256,000, and minus my 128,000, This is going to be $128,000. That is the consumer surplus. Now let's do the producer surplus. Again, I'm just going to go straight off the formula. This is going to be QP minus the antiderivative from 0 to t of the supply function. So S of x dx. All right, QP. We already had that from before. That's going to be the 1600 times 80. Then I'm going to subtract off the integral from 0 to q, which is 1600. And then I'm going to put in that supply function. The supply function is 2 times the square root of x, but I'm going to write it as x to the 1/2. That makes it so much easier to find the antiderivative. This will be 128,000 minus the antiderivative is going to be, I'll put the 2 out here, x to the 3/2. And then when I multiply, I need to clear that. So this will be 2/3. Then I'm going to evaluate that from 0 to 1600. So 128,000 minus 4/3 times 1600 to the 3/2. I'm just plugging in the 1600 for x. And then I'll do it again with 0. Well, this whole second term is just going to be 0. So I'm left with 128,000 minus $85,333.33. So I'm left with $42,666.67. This is the producer surplus. All right, there you go.